This is the conventional circuit diagram of transistor characteristics. Here we know that we are using the NPN transistor having common emitter configuration. So BC107 transistor we are using. So that we require two power supply, one for input and the other for output. Since it is having two junctions, to operate it, we need to bias the input side here, that is the through VBB, another through output side VCC. So emitter is made common to both base and the collector. And 100 kilo ohm we are connecting to the base, and 1 kilo ohm we are connecting to the collector. We are measuring voltage across VE between base and the emitter. We are measuring voltage, and current through the base IB. Here we are measuring voltage across collector and the emitter. We are calling it as VCE, and current through the collector is IC. So this is how these are the operators are required. Voltmeter, ammeter, and the two external power supplies are required, and two resistors, one kilo ohm, another is 100 kilo ohm resistors are required. So then, how do you do the experiment with the expEyes kit? Now let me explain the circuit diagram for the expEyes kit. So we know the transistor pin configuration. I am writing the NPN transistor. This is emitter. This is base. Then this is collector. And the emitter is made common. This will be connected to ground in the expEyes kit. And for the base, we are connecting 100 kilo ohm resistor. We need one power supply for the input side. So for that, I am connecting one DC power supply, that is PV2. We need to measure the voltage across B and E, VBE. For that I am connecting A2 in the expEyes kit. PV2 is the programmable voltage 2, gives plus or minus 3.3 volts, and A2 measures the voltage across base and the emitter. If I connect A2 to here, what will happen? It will read the supply voltage. That's why I wanted to connect A2 between the 100 kilo ohm and the base, so that it will measure voltage across the 100 kilo ohm resistor. Now I am connecting another resistor, that is 1 kilo ohm, to the collector. Then the collector end through the resistor will be connected to another power supply, that is PV1. PV1, programmable voltage 1, gives plus or minus 5 volts. I want to measure voltage across the 1 kilo ohm resistor because we don't have the ammeter in the expEyes kit. That's why we wanted to measure a voltage across the resistor. Through that we are going to know that what is the current through the circuit. So I need to connect A1 between collector and the resistor, so that it will read across the voltage across the 1 kilo ohm resistor. If I connect A1 at PV1 side, so that it will read the supply voltage. That's why I am connecting A1 to collector end. This is the circuit configuration, circuit diagram for the expEyes kit. This is a transistor. It has 3 legs: emitter, base and collector. You can see that close to notch is emitter, middle one is base, then the collector. Apparatus required: 1K resistor and a transistor and 100 kilo resistor. 3 columns of the transistor are connected on 3 different columns on a breadboard as shown in the diagram. 1 kilo ohm is connected to collector and 100 kilo ohm is connected to base as shown in the diagram. As per the circuit diagram, PV1 is connected to 1 kilo ohm and A1 is connected to collector. PV2 is connected to 100 kilo ohm and A2 is connected to base and emitter is connected to ground. Click on the expEyes software, go to RVCE tab, select physics RVCE and NPN characteristics. Uncheck the user defaults value, enter 0.1 volt for input characteristics. Click on start button. So it gives the input characteristics. We wanted to note down the data points. Initially, note down the data points. For constant VCE, IV versus VB has to be noted down. Wherever the repetitive values are there, write down the first values. And those readings has to be tabulated in datasheet. Like for 0.47, you have repetitive values. I have noted down only for the first reading. Next, the second trial for 0.5 volt, 0.5 VCE volt. Click on start button. Similarly, you have to note it down the data points for the second trial as well. Now the input characteristics is done. Go to output characteristics. For default value of 1 volt, click on start button. You are going to record IC versus VCE. For constant value of IB. Here also for repetitive values, we have to note on the only one data points. Likewise, you have to record minimum of 10 readings to plot a graph manually. So here also we can note down to find out the current gain. Okay, so for IB1 like 4.7 microamp, corresponding IC value has to be noted down. Wherever the constant value is there, that is the IC1. Now, for the second trial, the value of V base has to be set it for 2 volt. And corresponding IC versus VC has to be recorded. So it gives the constant IB value. For that constant IB value, corresponding IC2 value. So for this IB2 value, corresponding IC2 value has to be recorded. So we can see that the voltage is constant, so that in the table, in the right side column, you can see that wherever the constant voltage is there, that is IC2. So these two values help us to find out the current gain, IB1 and IB2, and corresponding IC1 and IC2. To plot the graph manually in this table, so wherever the corresponding repetitive values are there, only the first reading has to be noted down.